The first statement talks about the stock that fell the most in January. So let's sort it by January. Look at the stock that fell the most. The most negative value is for D. So we have D here, and then it's asking that this is the same stock that rose the most in June 2016. So for June 2016, yes, it did increase by a lot, but whether this is the highest value? No, there is an even higher value. Please remember to not get overwhelmed by such high values on the GMAT. There may be some other value even higher. So this statement is false. Come to the second statement here. The stock that represents the median percentage change in March. So let's sort it by March. The median value would be, in all there are 9 stocks, so the fifth value would give you the median value. The median value here, fifth value, is by stock F, and this should also represent the median price on 30th June 2016 is what the statement is saying. So let's now sort it by the price on 30th June and see whether we are still getting F. We got F the last time for March 2016. For 30th June 2016, the fifth value is again F. Yes, it is F once again, and therefore this statement is true. Come to the last one. The standard deviation of percentage change in price is more for G than for B. Remember, you don't have to manually find out the standard deviation ever. The GMAT doesn't ever expect you to find out the standard deviation manually. It will always expect you to have an estimate, understand the idea of standard deviation. It is always around how scattered the data is from a particular reference point, this reference point being the average of the data points. So for G, we see that the values are fluctuating between minus 1.2% to positive 0.9%. In all, the fluctuation is in a range of around 2.1%, and the average of these values would be around 0.1 to 0.2%. The values are scattered in such a way. For B, let's see, these are highly scattered values. From minus 9%, we have something to as high as 31.2%. So in all, the fluctuation here is of the magnitude of more than 40%. And therefore, definitely the standard deviation is going to be a lot more here compared to G. So no, it's not that the standard deviation for G is more than B, it's the other way around, and therefore this statement is false. The right combination of answers is false, true, false.